We're going to start looking at the chain rule, and the chain rule is a way of differentiating a composite function. A composite function would be like tangent of some polynomial, or some polynomial raised to a power. Okay, so it's going to be a function of a function. For example, if f of x is tangent of x, and g of x is x squared plus 1, then f of g of x would be f of x squared plus 1, which would be tangent of x squared plus 1. Okay, that's what a composite function is. We dealt with these in Algebra 2 towards the end of the year. Geotrig, we handled them probably towards the beginning of the year and revisited them several times throughout the year. But a composite function, f of g of x, that's chapter 2 of the Geotrig book, is where that's really highlighted, and then the topic arises a few more times just in passing. If you have a composite function, something looking like this, instead of tangent of x, you have tangent of stuff. And we use the high dollar word stuff to describe this, tangent of things, like in our stuff in here. Okay, you do the derivative of the function type. So the derivative of tangent is secant squared, right? So you do derivative of tangent secant squared of the stuff. Then you have to multiply that derivative times the derivative of the stuff. So the derivative of x squared plus 1 is 2x, right? So you do secant squared of x squared plus 1, but then have to multiply that times the derivative of this, which is 2x. So it's a chain rule. You're chaining it along, basically, is how it works. That's the idea. All right. So the main idea of these problems is if you can establish something as a composite function in structure, then you know you're going to apply this rule. And then you apply this rule very simply. Derivative of a function has some derivative. The argument of that function stays the same. Then the derivative of that argument becomes the next thing that rules along. So let's take a look at a few problems here. Example 1. F prime of x if f of x equals square root of x plus 1. It's not going to say f of g of x. It's just going to say f of x equals, and you're going to look at the structure of this thing and recognize it as a composite function. All right. If this said the square root of x, we know how to do it, right? We make it x to the half power, and we do 1/2 x to the negative 1/2, and we're done, right? All right. So what I want you to recognize here is the same thing is going to happen that we would normally do. If I see a radical in a problem, I don't want to do a radical. I want to do a half power. So we're going to write this as x squared plus 1 to the half power. If I'm looking at a power function, I'm looking for a base of x if I've just got a basic problem. X to some power, it's simple. If my base is anything but x, in this case x squared plus 1 is the base, now I'm looking at composite functions. I've got stuff to a power instead of x to a power. All right? So the way the chain rule works is this. F prime of x equals the derivative of this based on its structure. This is something to a power, so I do a power rule. I'm going to do 1/2 times the base to the negative 1/2 power. Okay. I differentiate like I normally would for the structure of the problem that I'm looking at. Okay, so it's a power structure. I do the power rule. Then I recognize that this has a derivative of 2x, so I have to multiply by that derivative of 2x. X squared plus 1 is a simple structure, right? Letter x raised to a power plus a constant 1. Derivative of x squared is 2x, derivative of 1 is 0. This is basically what we've been doing here for the last week or so, right? These types of problems. So when you get to a problem like we've been doing for the last week or so, that's the last step. That's the end of the chain. And that's the derivative of this thing. Okay, we could make it a little prettier. All right, that 2 is on the bottom, that 2 is on the top, right? So those cancel. This x is on top, this square root of x squared plus 1 is on the bottom. Beautify your answer a little bit. But that's how the chain rule works. Recognition of structure, it's a composite function, applying the chain rule correctly. Derivative of structure times derivative of argument.